No. 10, 12, part 3 of 12. So 3 of 12. Right. 1 over g of x equals 6. Is that it?
Yeah.
So 1 over g of x is 1 over g of x, 1 over g of x, so that's 1 all over 3x minus 2 equals 6. Is that not, that's not helpful, is it? What is? No. I don't know why, it's really big today for some reason. I don't know why. Because it's magnified, I suppose. Is it? I don't know. Right, anyway, you can see that for a minute. I'll try and sort it out in a minute. Cross multiply, right? Put the 6 over 1 cross multiply. So it's 6 multiplied by 3x minus 2 equals 1. Multiplying out, that's 18x minus 12 equals 1. 18x equals 1 plus 12, which is 13. Then divide by 18, so you get x is equal to 13 over 18. Is that right?
Yes. Do you know the way you use like the whole f(x) function? You use 3x minus 2 in the previous questions. I used the whole function when I put it in, and I got the wrong answer. So I didn't know.
Say that again.
So like, do you know the way it's 1 over f(x), so you know, so you put 3x minus 2
Yeah.
over under 1. In the previous questions when I was doing it, and I put the
Which
whole
question?
function, so like 12 part 1 and 12 part 2, like if I were to do g of minus x.
So g of minus x means into g, everywhere you see an x, put in a minus x. So it would be, so you have to get g of minus x. So instead of that, it's 3x minus 2. So 3 times minus,
Oh, so you don't.
and the answer is equal to 6.
By minus, do you?
No,
Oh.
no, it's just everywhere you see an x.
Yeah.
It's different to, that is different to minus g of x.
Oh, okay. Yeah.
Okay, so minus g of x would be multiply the whole function by minus.
Yeah.
And g of minus x means instead of the x, put in a minus x.
Oh.
Is that alright?
Yeah.
Okay, so I don't know what's going on with this screen. That's not helpful either. Yeah, look, I'll try and fix it there another time. Right, okay, we'll make do. Right, that was number 12, and then you had number 14. Any problems with number 14? No? Anyone? Anyone? No. Right, the next page then I gave you, the next section I gave you 1 to something, no, 2 to something, 3 to 10. Okay, so anyone need number 3 done? 4, 5.
Can you do 4 part 2 after?
4 part 2, no bother. Right. I don't know what's going on. I need to stop breathing. 4 part 2. 4 part 2 is g f of x, yeah?
Yeah.
Right, so it says f of x is 2 to the power of x minus 1. G of x is 3 plus 4x. And they asked me for, where is it? G f of x, G f of x. So that's g after f of x, so do f of x first. So f of x is 2 to the power of x minus 1. So put that in instead of x. So it's 2 to the power of x minus 1. Is that okay? Sorry, the bracket should be like so. Right, okay, so what they've done is change that, because that's 2 to the power of, change the 4 to a 2 to the power of. So 2 to the power of 2 multiplied by 2 to the power of x minus 1. So this is going back to junior cert. You want to multiply, so what do you do with the indices to multiply? You add the indices, so that's 3 to the power of 2 to the power of 2 plus x minus 1, which would be 3 plus 2 to the power of x plus 1. Right, listen, if you got that far, mark it right. Okay, right. Is that okay? That's number 4. So that's just going back to kind of junior cert indices. Right, but if you got this far, I'm happy for the moment. Right. Okay, that was number 4. Anyone need number 5? Number 6?
Yeah, can you do number
6, yeah. Okay, so number 6. The whole top is missing off it. What's that is? Better. Yeah, that's better, isn't it? Right, number 6, so right, so number 6, f of x is s plus tx g of x is equal to x squared minus 4, and the next one, h of x is equal to 3x plus 1.
That's question 8.
Is it? Sorry, I'll probably end up doing question 8, will I?
Yeah.
Can I finish question 8 and I started and I'll go back and do 6 in a minute? Right, okay, because I presume you'll want me to do question 8. Am I right? Yeah? Okay, so seeing I wrote it down by accident, I'll go back and do 6. So it goes h, g, f of x equals 4 times 3x squared plus 3x minus 2. Okay, so I'm going to deal with this side first, right? So that's h after g after f of x. So that means do f of x first, which is s plus tx. Then put the answer from f of x into g. So that means I have to put the answer, which is s plus tx, I have to put that into g. So that's g is x squared minus 4. So I'll go x plus tx to be squared minus 4. Is that okay? I'm going to square it out. Square the first, twice the first by the second, stx, square the last, plus t squared x squared minus 4. Is that okay? Just square that out because I'll have to in a minute anyway. Then take that answer and put it into h. So that means I have to do h of s squared plus 2stx plus t squared x squared minus 4, and I need to put that in. Everywhere I see an x, put in all of that. So it's 3 times s squared plus 2stx plus t squared x squared minus 4 plus 1. So it's 3x plus 1. Is that okay? Multiplying out, that's 3s squared plus 6stx plus 3t squared x squared. Then I have 3 by minus 4 is minus 12. Minus 12 plus 1 is minus 11. Is that okay? I just do 3 4s and 12. Minus 12 plus 1 would be minus 11. Are we okay? Right, okay. But they told me when you work all that out, so when you work 3s squared plus 6st tx plus 3t squared x squared minus 11. When you work all that out, you end up with this. I'm going to multiply into this bracket if that's okay. So you end up with 4 times, I'll move it up now in one tick. So when you work all that out, if you multiply into that bracket, you'll get 12x squared plus 12x minus 4 twos are 8, yeah? Okay, is that alright? Now this is equality of equations, so you let the x squared term on one side equal to the x squared term on the other side. So the x squared term over here is just 3t squared x squared. So you let that equal to 12x squared. You let the x term here, which is 6stx, equal to the x term over here, which is 12x. And you let anything without an x in it over here, which is 3s squared minus 11, you let it equal to anything without an x in it over that side, which is minus 8. So we did that in algebra, where you pick out the x squares on the left equal to the x squares on the right. The x's on the left equal to the x's on the right, etc. These cancel, and you get 3t squared equals 12. I can solve here, so I get t squared is equal to 4. Right, this number 8. Right, t could be plus or minus 2, because plus 2 squared give me 4, minus 2 squared give me 4. But in the sum it tells me t, s and t are natural numbers. They're an element of n, so that means I just need to take the positive. I don't need to take minus 2. Is that alright? Okay. Over here, knock off the x's, so I get 6st equals 12. Yeah. So I've just figured out that s is, or t is 2, so that's 6s times 2 equals 12. So that's 12s equals 12. So that means s is equal to 1. Right, I don't need to work out this because I solved for s and t, but I could just use it as a check. S squared, 3s squared equals minus 8 plus 11, which would be 3. Divide by 3, you get s squared is equal to 1. So if they didn't tell me s was a natural number, it could be a plus or a minus 1. But because s is a natural number, it has to be 1. So I end up with the same answers. Just a little check to make sure I was right. Didn't need to do this. If I was in a rush, I wouldn't have done this. Okay? Are we good? Right, I'll go back and do number 6 now. So number 6. Two functions are defined by f of x is equal to 2x plus 3 and g of x is equal to 2x minus 3. Part 1, find expressions for f g of x, and then part 2, find an expression for g f of x. Okay, so do g of x first, so that means my answer to the first bit is 2x minus 3, and then stick that into f, so it's 2 times 2x minus 3 plus 3. Is that okay? Multiplying out, that's 4x minus 6 plus 3, which is 4x minus 3. Okay, this one do f first, so I do get my answer to the first bit is 2x plus 3. And then stick that in instead of x here, so it's 2 times 2x plus 3 times, or minus 3. So multiplying out, that's 4x plus 6 minus 3, which is 4x minus 3. Is that okay? It's a plus 3, thank you. It is plus 3. Right, okay. Then the second bit asks me determine the least possible value for the product. So 2g of x multiplied by, I'm going to put a dot for the multiply so I don't think it's an x. Is that okay? So basically I want to multiply my two answers. So multiply my two answers and see what happens. So one answer is 4x minus 3. The other answer is 4x plus 3. Right? If I know my factorizing, I know that's the difference of two squares. So that originally started as 16x squared minus 9. Or you could just multiply out and the x's will cancel. Is that alright? Now I want this number to be as small as possible. Right? So I want this number to be, because they want the least possible value. Right? Okay. So no matter what I fill in for x here, whether I fill in a positive or a negative, that'll end up being positive, won't it? The first term will end up being positive. So, like if I fill in a 1 or a minus 1, I'm still going to end up with the same answer, aren't I? If I fill in a 2 or a minus 2, right, I'm going to end up with the same answer. Would you agree? So the smallest, to make that as small as possible, what should I fill in for x? 0, yeah? So it's 16 times 0 to be squared minus 9, and that works out to be minus 9. Because if you put in a 1, it would be 16 minus 9, which is 7. It's bigger than minus 9, isn't it? If I put in a minus 1, again I'd end up with 7. If I put in a minus 2, you'd end up with a bigger number again. Is that alright? Put in a 2 or a minus 2, it doesn't matter, okay? So that's just, there's no method there, as in it's just think about it. Okay? Right, are we good? 7. Can I do part 2? I can. Can I go? Right, so 7 part 2. Right, so 7 part 2 is f of x is equal to 2x plus 1. And g of x is equal to 3x plus c. Right, find m if f squared m, right, is equal to m. Okay, girls, the reason you weren't able to do that is because I hadn't told you what f squared means. Right, so what f squared means, it means f m. So read that, it's f after f of m. So you have to do f of m first, and then put your answer into f again. Yes? Yeah. So you have to do f of m first. So f of m first would be 2m plus 1. And then you have to take the answer and put it into f again. So you have to do f of 2m plus 1. So that's what f squared means. Girls, I didn't tell you about that the last day. Okay, so I'm telling you now. F squared means f after f. So f after f means put it into f, get the answer, and put the answer into f again. So that would be 2 times 2m plus 1. So, plus 1. Sorry, 2x plus 1. Is that alright? Multiplying out, that's 4m plus 2 plus 1, which would be plus 3. Okay? Is that alright? And they tell me that when you work all that out, they said you get m. So equal to m. Then m's on one side, numbers on the other. Bring over that m, becomes a minus m, so I'm left with 3m. Bring the 3 that way, it becomes a minus 3. Divide each side by 3, and you get m is equal to minus 1. Is that okay? So you couldn't do that because you didn't know what f squared means. Do you know what f squared means now? It means f after f. So put it into f, take the answer, put it back into f again. Right, are we good? Right, okay. How am I going for time? Where's my phone? Very deep. Oh great, I've loads of time, so to move on to the next section. Okay, right, so the next section is got to do with types of functions. Right, so there's 3 types of functions. We've injective, surjective and bijective. So injective, surjective, bijective, right, again you have to learn what they mean. Not going to jump into your head, okay? So an injective function, sometimes called one-to-one, right, okay? So every output has a unique input, right? Okay, so every output, as in every thing that comes out, has a unique input. So that means no arrows go to, no output has more than one arrow coming into it, right? It's okay if they've no arrows coming into it, as in that's still surjective. There's an extra point there. It's got no arrow coming into it, that's okay. But every output, so every dot in here has a unique input, as in there's never, like that would never happen, as in there's never one going to, that would never happen, where this output has two inputs, that will never happen, okay? So every output has a unique input, and it's okay if they've no input, right? But so you can't have two arrows coming in. These are out the arrows coming in. There can't be two arrows coming in. It's okay if there's no arrow coming in, but there can't be two arrows coming in. Is that okay? Or more than one arrow coming in. So every output has a unique input, right? Right. So every output has at most one input. So every output has at most one input. So it's okay if it has none, right? But it can't have, every output can't have two inputs. As in, you know the way sometimes one might go to two and four might go to two, right? That's not a surjective function. It's still a function, just not a surjective or an injective function. Sorry, I'm on injective. It's not an injective function. Right, so how do you know from a graph, right, okay, if a function is injective? So from a mapping diagram, you just make sure there's only at most one arrow coming in. So at most one arrow coming in. So at most means 0 is fine, right? So at most one arrow coming in. Is that okay? Right, how can you tell from a graph? Right, we do what's called the horizontal line test, right? So if you have a graph, right, any horizontal line hits it at most once, right? So any horizontal line hits it at most once, right? So here's the graph, right? If you draw, remember this is a line, so it goes on forever. So if you draw any horizontal line anywhere, right, on the grid, anywhere on the grid, it hits it at most once, doesn't it? It never hits it twice. So this function here is injective. I'm on injective. This one here is injective, right? Whereas this one here, right, if I have a curve like that, if I draw a horizontal line, it's hitting it twice, isn't it? Is that okay? So it's hitting it twice, would you agree? So this is not injective. So this is not injective. So this one is injective because the horizontal lines hit it at most once. This is not injective, right, because the horizontal lines hit it twice. The horizontal line down here is okay, it doesn't hit it at all, that's fine, because it's at most once, but the horizontal lines up here hit it twice. So that means it's not injective. Okay? So these are new words, new concepts, you have to learn them. Okay? So it doesn't matter where you draw the horizontal line, as long as it hits the graph at most once. If it hits it at most once, at most means one or less, right? So if it hits it at most once, then it's injective. If it hits it more than once, it is not injective. Okay? So this one is injective, the line. This one is not injective because it hits it twice. Are we good? Right? So then I'll move on to a surjective function. Yeah, back. Sorry, you weren't ready. Sorry. Can I go? Am I good? Right, surjective, so is the second type of function. Right, sometimes they call it surjective many to one. Right? Every output has at least one input, so this time it doesn't matter if there's two arrows coming in. It doesn't matter if there's two arrows coming in, right? Okay, but you can't have a blank one. There has to be an arrow coming in. So there has to be at least one input. For every output, there has to be at least one input. Here we have an output with no input, so that's not surjective. But if that dot wasn't there, it is surjective. So it doesn't matter that this output has two inputs, right? It just has to have at least one input. Okay, so that's one or more inputs. Right, so from a mapping diagram, that's what a surjective function looks like. Right, from a graph, it hits it at least once. So for example, here's a right, are we good? No. It's alright, it's fine. Yeah. Right, are you ready for my horizontal line test on the graph? Good. Okay, look at this one. Right, remember this goes forever that way, and this one goes forever that way. If I draw any horizontal line, right, any horizontal line anywhere on the plane, it hits it at least once, doesn't it? Right, it hits it at least once. Would you agree? So that makes it surjective. Whereas if I had something like this, right, something like this, okay, I can draw a horizontal line here, can't it? And it doesn't meet it at all. It's fine up here, it's hitting it at least once, but down there, it doesn't hit it at all, sure doesn't, right? So this is not surjective. Because in order for it to be surjective, it has to hit it at least once. And how I remember these, it took me a long time to figure out, to remember it, because my head was wrecked from it. I remember the word slim. Okay, which is something I will never be, right? Okay, so I remember the word slim, surjective at least once, injective at most once, right? Okay. So, I don't know, is that helpful to you? If that's more confusing. So, as for a surjective function, the horizontal line has to hit it at least once, L for least. For an injective function, the horizontal line has to meet it at most once. Okay? Is that right? Okay. Right, which brings me finally to the last one, which is a bijective function. And a bijective function, it has to be both, right? So a bijective function is both injective and surjective. And surjective, so it's both. So if it hits it at least once and at most once, that means the horizontal line test, it hits it exactly once. So all horizontal lines hit it exactly once. Hit the graph exactly once. Okay, just give me a sec. So let's have a go at some of these. Let's see if we can make head nor tail of them. So let's go page 245 to 246. Let's do 1 to 10, because most of them are just, is it injective, is it surjective, is it bijective? Right, okay? 245 to 246, 1 to 10. Am I putting up a picture? Yeah, okay. Are you getting your test back? I just got one today, so I have one to correct, and then I have the rest of them corrected. So I'll get back to you tomorrow.